Next topic we have to study is the perturbation theory to particle in one-dimensional box with a slanted bottom. In this case, consider a one-dimensional box of length capital L and a uniform electric field of strength F is applied into the system. A uniform electric field of strength F is applied into the system. In the absence of electric field, there is no perturbation in the system. In the absence of an electric field, there is no perturbation in the system. If we applied the potential F or electric field strength F applied into the system, there develops a potential or there develops a perturbation. There develops a perturbation. And that perturbation will be equal to E into F. If we apply an electric field of strength F into the system, in the one-dimensional box develops a perturbation that is E into F. Okay. Suppose the potential energy of the system V equal to EFX. Potential energy of the system V is equal to E into F into X. Then at V equal to 0, the value of X equal to 0. V equal to 0, the value of F equal to 0. Sorry, at X equal to 0, the value of V equal to 0. At X equal to 0, the value of V is equal to 0. And at X equal to L, the potential energy will become V is equal to what? In place of X, we substitute L. So we get EFL. V is equal to EFL. At X equal to L, V is equal to EFL. That means at X equal to 0, the potential energy is 0. When we goes to the other end of the box, that is at L, the potential energy will become EFL. The potential energy will become EFL. That means there is a rise in potential energy. There is a rise in potential energy from 0 to EFL. That is, this is the rise in potential energy. So the system is considered as a one-dimensional box with a slanted bottom, because at X equal to 0, the potential energy of the system is 0. And at X equal to L, the potential energy rises and it will become V is equal to EFL. Okay, are you understand? Okay. Then in the absence of an applied field or applied electric field, there is no perturbation. So the unperturbed Hamiltonian can be written as H cap 0. The unperturbed Hamiltonian will be H cap 0. That is also known. That is H cap 0 equal to minus H square by 8 pi square m into d square by dx square. H cap 0 equal to minus h square divided by 8 pi square m into d square by dx square. And the unperturbed wave function psi n0 is also known. That is psi n0 equal to root of 2 by L into sin n pi by L x. Sin n pi by L x. Similarly, the unperturbed eigenvalue En0 is equal to what? It is n square h square divided by 8 ml square. So the values of unperturbed system is known, that is h cap 0 is known, psi n 0 is known, and en 0 is known. Then we have to find out what is the perturbed Hamiltonian h cap. H cap equal to h cap 0 plus h cap prime. And perturbed Hamiltonian is h cap equal to h cap 0 plus h cap prime. Then h cap 0 is what? It is minus h square divided by 8 pi squared m d square by dx square plus h cap prime is the perturbation. It is the perturbation. So that is given by EFL. It is not EFL, it is the potential energy term, that is EFX. EFX is the perturbation in the system. EFX. So h cap equal to minus h square by 8 pi squared m into d square by dx square plus EFX. Then we have to find out the first order correction to the energy. In order to find out the first order correction for energy, we know the values of ground state unperturbed energy. The ground state unperturbed energy is given as E10 equal to h square by 8 ml square. It is the ground state, first order ground state unperturbed energy, and the correction to this energy is given by E1 of 1. E1 of 1 is equal to integral 0 to L psi 1 0 h prime psi 1 0 d tau. It is actually psi 1 0 star h prime psi 1 0 d tau, but the wave function is normalized, or it is a real function. The wave function is real function. So integral 0 to L psi 1 0 h prime psi 1 0 d tau. We have to substitute the value of psi 1 0. Psi 1 0 is what? Psi 1 0 equal to root of 2 by L into sin pi by L x. Sin pi by L x. Integral 0 to L root 2 by L sin pi by L x into h prime is what? H prime is EFX into root 2 by L sin pi by L x dx. In place of d tau we take dx. E and F are constant. 2 and root 2 by L is also constant. Root 2 by L into root 2 by L, 2 by L. So this equation becomes 2EF divided by L. 2EF divided by L, integral 0 to L. This x into sin pi by L x into sin pi by L x is sin square pi by L x dx. 2EF by L integral 0 to L x sin square pi by L x dx.